Today we are here for an online workshop on decision tree using STATCRAFT R. So we have with us Dr. Dhaval Maheta sir, who's the resource person for the session. I'd like to introduce Dr. Dhaval Maheta sir is a doctorate in management and currently working as professor, Department of Business and Industrial Management, Veer Narmad South Gujarat University, Surat. Sir has 20 years of postgraduate teaching experience and above industrial experience. Sir has presented and published 40 research papers in national and international conferences, and he has been the resource person for the research methodology workshop organized by various levels, including NITs and IIMs. And if any queries, you can write it in chat box. By end of the session, we can discuss one by one. I will hand over the session to Dr. Dhaval Mehta, sir.
So today I'm going to present about decision tree, and the algorithm which we are going to talk about is RPART and C5 algorithm. Now let's see what is a decision tree and why its popularity has recently increased in predictive analysis. Basically, it is one of the tools for machine learning, which is considered to be a very easy tool in machine learning. I'll take one very small example. There is a small example on your screen that we have to predict that the John will play the tennis or not, right? This example has been given in many books, and I will repeat the same example. So what are the factors which contribute that the John will play or not? So the day is there, the outlook is there, the humidity is there, the wind level is there, and the target variable is John will play or not, right? So we want to find out that under what conditions John plays the tennis. Now in total, there are 9 times when John has played the tennis, and there are 5 times when John has not played the tennis, right? Now, what we want to do is we want to train the algorithm. We want to train the algorithm by using the data. And when we give the new data set, we want to predict that will John play or not. So the things will get bifurcated when you will run the decision tree based on the purity of the node. What is the purity of the node? There will be node and there will be branches. So if I talk about the overcast, now see the outlook. Okay, what is outlook? Let's go back. Outlook is this variable. So if it is overcast, irrespective of the humidity level or the wind level, John plays the cricket. But the story is not the same with the sunny day or with the rainy day. In the sunny day, right? In the sunny day, there are 2 yes and 3 no. And in the rainy day, there are 3 yes and 2 no. This means that these are impure nodes. Please remember one thing. These are impure nodes. There is an impurity in the node. But if I talk about the overcast, they are pure nodes, right? So again, the humidity will be divided into 2 parts, high humidity and normal humidity. And here wind will be divided into weak and strong. And on that basis, we will do the prediction that will John play the cricket, will play the tennis or not, right? Now, this is also known as a greedy algorithm. So it is not greedy, it is a greedy algorithm. Greedy algorithm means it will go for infinite divisions. If you don't control, it is like a bushfire in the data set. It will go on dividing it. And therefore, sometimes we will have to put the restriction. We will have to put the restriction that the minimum number of observations in the node should be this much. Minimum number of splits should be this much. So we have to put the restriction in the decision tree so that it does not go on infinite division. And therefore, it is known as a greedy algorithm because it goes on dividing it. It goes on dividing, splitting, provided the data set. Let's proceed further. Now, we have seen the scenario that when there is an overcast, yes, when humidity is normal, Yes, John plays the tennis. When humidity is high, no, it does not play. Similarly, here also. So, if the new data is given to you, so if it is outlook, humidity is high, okay. If it is an outlook is rain. Please be with me. See that this is the new data which I am giving to you. The outlook is rain, humidity is high, and winds are weak. Will John play the tennis or not? Please say yes or no. Will John play the tennis or not? Why no? Why no? Why no? Okay. So, yes, it will play the tennis. So, which are the algorithms which are available to us? There are in total 6 algorithms which are used in the decision tree. Iterative dichotomizer, C4.5, CART, then Jade, Mars, and Quest. ID3 is it is a classic algorithm for decision construction, for decision tree construction, which uses entropy as a measure of impurity. Now there are different measures of impurity. What do I mean by pure nodes and what do I mean by impure nodes? I have already explained, friends. See, this is a pure node. Pure node means the decision is clear, either yes or no. Whenever the decision is perfectly clear, 100% clear, yes or no, they are known as a pure nodes. But when we are dicey, that this can also happen and this can also happen, then there is an impurity in the node. Impure nodes are, you can say, are worst for taking the decision, right? So let's proceed further. So there are some measures to detect the impurity in the nodes. One of them is entropy, another is a gain ratio, another is a Gini index. Okay. So C4.5 is an extension of ID3 algorithm that can handle both continuous and categorical data. C4.5 uses the concept of gain ratio instead of information gain to overcome the biases. CART, classification and regression tree. Basically, we are going to talk about second and third algorithm today. It is a popular algorithm. The CART is a popular algorithm for decision tree constructions that can handle both classification and regression problem. CART uses Gini index as a measure of impurity and reduction in Gini index as a measure of attribute relevance. Then comes the CHAID, that is a chi-square automatic interaction detection. It is an algorithm that builds decision tree based on the chi-square test, right? So we are having newer and newer type of algorithms. Today we are going to discuss second and third one. Let's proceed further. Which attribute to split on, right? The question arises that when the algorithm runs, which parameters should be considered for splitting purpose? Should we split from outlook, or should we split from wind? Now, whenever you will run the decision tree, irrespective of any software, it will always generate the different tree based on the node it picks up. So we want to measure the purity or the impurity of the node. And on that basis, the node will get split. So if I talk about this overcast, it's a pure set, 4 yes, 0 no. So it's completely certain. It means that this is a pure node. If I talk about this one, strong, 3 yes and 3 no, completely uncertain, right? Impure node. Now, what is the problem with this approach? Many times decision tree overfits the data. It means that it goes on splitting till each mode contains one example. This is to be avoided. It will go indefinitely splitting. You cannot stop it. It is a bushfire in the data. The decision tree should stop splitting when not statistically significant. Grow, then post prune based on the validation set. So I will explain to you what is pruning, what is splitting. So subtree replacement pruning can also be done. Can you see on the screen how we are going to capture the entropy? Please write down yes. Please write down, can you see on the screen what is entropy? Okay, very simple. There is a formula, but I'll try to explain it in a very, very simple way. The entropy will be captured by minus P log to the P minus P log to the P, right? So if I talk about the impure node, 3 yes, 3 no. So how it will capture the probability 3 by 6 log 2 3 by 6 minus 3 by 6 log 2 3 by 6. So it is 1 bit. It is 1 bit. If I talk about the pure node, what will happen? 4 by 4 log 2 4 by 4 minus 0 by log 2 0 by 4 0 bit. So if my entropy is 0, the node is pure. And if my entropy is 1, it is an impure node. Please write down on one page. Please write it down on one page. Anybody who is not able to understand this part, feel free to discuss with me. See, P plus the probability of the positive, P minus the probability of the negative, 3 yes, 3 no, probability of positive, 3 by 6, 3 by 6, probability of negative, 3 by 6, 3 by 6. Similarly, if I talk about this 4 yes, 0 no, probability of positive, 4 by 4, probability of negative, 0 by 4. And on that basis, the entropy is calculated. When many items are there, right? When we are having many items, then we calculate the entropy of all of them. See, 9 yes and 5 no. If I want to calculate the entropy of this, so the probability of yes, probability of no, 9 by 14 log 2 9 by 14 minus 5 by 14 log 2 5 by 14. So I got 0.94. Nearer to 1, impure node. Nearer to 0, pure node. Is it clear? Please write this thing in the chat box so that you can remember for the lifetime. Entropy nearer to 1 is an impure. Entropy nearer to 0 is the pure node. Shall I proceed further? Fine. Thank you. Now, what are the problems with the information gain? It is biased towards attributes with many values, won't work for the new data, and therefore we calculate the gain ratio. Okay, we calculate the gain ratio one level higher. So the impurity measures normally vary from 0 to 1. Our model varies from 0 to 1. So orange is for cross entropy, a new measure to detect the purity or impurity in the node. Gini index, again, to detect the purity or impurity. Don't worry, friends. I will explain Gini index also. Have patience. I'll make the thing so simple that you will be able to remember this for lifetime, right? Then classification error rate. How much is the classification rate? Can you see on the screen the table which is there? Say yes or no. Can you see on the screen? Right? Just see the X variable. Just see the M variable. Just see the N. Just see Q, R. Have a perfect graph is there? No, there is no graph. There is a table. Mr. Ketan, there is a table. There is no graph. It's not a graph. It's a table. Okay. No table. Madhusudan sir, can you see the table? X, M, N, Q, R? I think there is a lag which is coming.
No, sir, we are not able to see, sir. Now it's visible, sir. Yes.
Yeah, so there is a lag which is there. Okay, now the table is visible. Fine.
Yes,
good. See the table carefully. Observe the table carefully. X I am varying from X1, X2 to X8. But when I am varying M, there is a pattern. M1, M2, M1, M2. And in N, there is a pattern is N1, N2, and N3. In Q, there is a varying pattern is Q1, Q2, and Q3. And in R, The target variable is having only two response, R1 and R2. Now, let's say that what is the probability that if the model is not there, the R1 has turned green. Can you see the R1 which has turned green? Is R1 turned green? Say yes or no. So what is the probability that the event R1 will occur? What is the probability? I'm not trying to say you give me in decimal. What is the probability? There are total 8 events. So R1 is 3 by 8. Okay. Is it clear? It's 3 by 8. Very nice. What do you say about R2? What do you say about R2? Friends, 5 by 8. Very nice. So your Gini coefficient is so simple. 3 into 8 multiplied by 5 into 8. And your Gini is 0.23. Shall I proceed further? Shall I proceed further? Okay. Now let us make the things little bit complicated. Okay. Little bit complicated. When M1 is there, what is the probability of R1? When M1 is there, how many R2 has occurred? When M1 is there, how many R2 have occurred? Is it clear? When M1 is there, how many R2 have occurred? Fine. And when M2 is there, how many R1 has occurred? Right. So again, what we will do, the occurrence of M event is 50%. In M1, this is M1. M1 happens 4 times out of 8, while M2 happens for 4 times out of 8. So in case of M1, R1 does not happen only, so its probability is 0 by 4, while R2 happens 4 times out of 4, so its probability is 4 by 4. Is it clear? See, in case of M1, R1 does not happen only, so its probability is 0 by 4. Right? Only R2 happens. So if I talk about M1, right? So half of M1, because M2 can also be there. So half of M1, R1 does not exist. The probability of R1 and probability of R2. So this will give me the Gini coefficient. Similarly, in case of M2, R1 happens 3 times out of 4. So its probability is 3 by 4. While R2 happens 1 time out of 4. So its probability is 1 by 4. So the Gini for M is half into 0 by 4 multiplied by 4 by 4 plus half into 3 by 4 into 1 by 4. Anybody requires repetition? Be frank enough. Be frank enough. Do you require repetition or you have understood it? Have you understood this part? There is a little lag. Okay. Anybody requires repetition for this Gini? Anybody requires? Okay, I'll repeat it. See, when the condition is, when M1 is active, is R1 occurring anywhere? Just check all of you. When M1 is there, is R1 occurring? When M1 is on here, is R1 occurring? No. It means that, okay, what is the probability of M1 and M2? Half. When M1 is active, R1 does not occur. Only R2 occurs. How many R2 occurs? 1, 2, 3, and 4. This means that half of M1, R1 does not occur, so 0 by 4. R2 occurs 4 by 4. So we have got the Gini of M. We are Gini of M for R1 and R2. Now, let's talk about M2. When M2 is there, see friends, M2 is there. R1 is also occurring and R2 is also occurring in M2, right? And therefore, in such scenario, what will happen? In case of M2, R1 happens 3 times out of 4, so its probability is 3 by 4, while R2 happens 1 time, so its probability is 1 by 4. So on that basis, the Gini is calculated, right? So we will calculate Gini of M, Gini of Q, Gini, and then we will calculate Gini gain, right? So Gini gain is the total Gini minus the Gini of M. And we will get Gini gain of M, that how much this particular variable is able to explain, right? Let's proceed further. We are going to use C5 and RPART algorithm. Can you see the difference? Can you see the PPT on the screen, all of you? Can you see the PPT of the difference? The difference between C5 and RPART? Just wait a minute, it will be there. Just wait a minute. Just a minute. There is a lag which is there. Yes, no need to worry. It will come. No need to worry. It will come. It will come. Right? Is it appearing? The slide is difference between C5 and RPART. RPART is implemented in R programming language, while C5 is implemented in C++. RPART uses the Gini index or the information gain to determine the best split at the each node. Entropy based splitting. So basic difference between all this algorithm is how they are detecting the impurity, and different algorithms use a different impurity measures. RPART has an option to handle the missing values, but C5 does not have it. RPART uses cost complexity pruning to prevent overfitting, while C5 uses a simpler rule-based pruning technique. C5 is generally considered to be more complex and computationally intensive than RPART, particularly for large data sets. There are some advantages of RPART. RPART is very easy to understand because it will generate a decision tree. It can handle the missing values. It is fast on training, and the interpretability is quite easy. The disadvantages: RPART uses cost complexity pruning to prevent overfitting, limited splitting criteria, and not suitable for complex relationships. When I talk about C5, it can handle the categorical variables, which is not possible in CART. It can handle the complex relationship. Accuracy is quite high. We will compare the accuracy of CART and C5, both of them, and we will try to find out which algorithm suits better. Friends, you will have to do the trial and error to find out which algorithm suits better to your data. Disadvantage: it is quite slow because it is a dichotomizer and it is slow. Limited feature selections, and its interpretability is little bit difficult, and therefore it is not so popular. Which is better? It depends upon missing algorithm, how much complex the data is. It depends on that. Now, building a decision tree. First of all, see this on your screen. I'm just waiting for the screen to display. There is a decision tree which I have drawn, right? This is there in my book. I have taken the example from my book. Can you see 100 divided into 70 and 30? Can you see? Right. Now see, there are 100 cases which are there. 100 cases which are there. If we allow the algorithm to run infinitely, it will happen that it will go on dividing till the last one case also. So there will be one leaf. The last leaf will have one case, only one case, a very specific condition, only one case. We don't want this algorithm to divide indefinitely. So there is something which is known as depth, maximum depth. The 100, this is the first layer and this is the second layer. So the what we can specify is the maximum depth. The maximum depth of this decision tree is 2. Is it clear? The maximum depth of this tree is 2. Is it clear? Okay. So this is the first restriction which has been put by us on the decision tree, that you will not go beyond 2. First restriction. The second restriction we will put on the nodes, right? Minimum split will not allow any node having sample less than 70. So if any node is having the number less than 70, no further division will be allowed. So see, this 30 is not divided, but 70 is divided. Below 70, the division or the splitting will not be allowed. Second restriction which we have put on the decision tree. Clear? Is it clear? Is it clear? Say yes or no. So this is the minimum split. The third one, the minimum bucket size. The minimum bucket size should be, so I will specify that if any bucket is less than 20, don't make the bucket, club it into another. Minimum bucket size I can specify. So how many restrictions I can put? Friends, can you tell me how many restrictions we are putting one by one? Please put in the chat box how many restrictions we are putting. 3. 1, the depth. Second, the splitting. And third, we are putting on the leaf node. Okay. Now, see the splitting. In decision tree, the data is partitioned into subsets. The criteria for subsetting the particular variable are determined from the predictor variable used for the subsetting and the set of the values from where it will split. The split is based on the particular criterion. I have already explained. The criteria we will consider is the Gini. The Gini is used for the splitting. Then comes the pruning. Pruning solves the issue of overfitting. It is a process in which we try to reduce the size of the tree by turning some branch nodes into the leaf nodes and removing the leaf node under the original branch. Quite technical. Let us make it simple. Just a minute. Okay. It is necessary because sometimes decision tree works well on training dataset but may not fit on the new dataset. So pruning is necessary. Tree selection. There are many trees in the forest. Which tree you will select? Every time when you will run the algorithm, it will give you the new decision tree. Which decision tree you will select? And that's the reason we have came up with the concept of low cross-validated error. And on that basis, we will select the best tree. Now tuning the parameters. When you will operate the STATCRAFT, it will give you some priors, minimum splits, the maximum depth which we want, the loss matrix. Let's see one by one. Priors. The probability of occurrence of the good event and the bad event. How much probability I can assign? The probability of success and failure. Anybody can tell me how much will I assign? The priors. What will be the probability of success and failure? Probability of heads and tails. What is the probability? 50-50. Correct. So when I'm specifying the priors as 50-50, so the algorithm will work that way. But there can be a possibility, there can be a scenario, there can be a cases in finance, in marketing, that the probability is not divided into 50-50. For example, there are 70% probability for surviving and 30% for not surviving. So here our priors are 0.7 and 0.3. So the probabilities are different. Probability of getting the COVID, probability of not getting the COVID, the probability is not 50-50. And therefore, we are setting the priors. Then comes the minimum split. The minimum number of values in the node that must exist before split is attempted. I am talking about this part, friends. Minimum split. This one. This I have to specify. Minimum split. Consideration. As a rule, many programs and data miner, this is not necessary. Maximum depth. Maximum depth is the length of your decision tree. This I have already explained. See on your right hand side, maximum depth. How much the decision tree should split? How many times? 1 layer, 2 layer, 3 layer, how much? The accuracy of the decision tree algorithm will depend on the confusion matrix, as our target variable is categorical. Normally, we use the decision tree when our target variable is categorical. So how to evaluate, how to consider that our algorithm is fitting properly? And for this reason, we generate the confusion matrix, also known as classification accuracy, also known as area under the curve, also known as receiving operating characteristics. Everything, all these statistics are generated from one table. From this one table, we will be generating the sensitivity, the specificity, the F1, the recall, everything will come from the same table. And that's the reason we have to understand what's a confusion matrix. Now, here, first of all, I'll talk about the COVID. A person is having a COVID and we are having a kit to detect it. We are having kit to detect it. So a person was having a COVID and the kit detected it, that yes, that a patient is having a COVID. 50 such cases are there where kit was successful. The COVID kit was successful in detecting that a person is having a COVID or not. Let's talk about this normal. A person was normal and the kit detected that the person is normal. So 114 are such cases which were correctly classified by kit. The correct classification is 50 plus 114. Kit was successful here also and kit was successful here also. You are having a disease. Your blood report detected correctly. You are not having the disease. The blood report detected correctly. So what is your success? 50 plus 114, 164 is your success. Misclassification has happened here. A person was normal, but the kit detected it that he is having a COVID. Here, a person was having a COVID, but the kit detected it as normal. So 22 plus 6 is an error in the model, the leakage in the model, the misclassification in the model. So 28 are such cases. Your algorithm is successful when we are having more and more correctly classified cases. Now see on your right hand side, the doctor is diagnosing that you are pregnant, right? Doctor is diagnosing that you are pregnant, right? Now let's talk about you are not pregnant, right? True negative. This cannot happen only. You are pregnant. False positive, right? You are not pregnant, right? So false negative. Is it clear? True positive, true negative. So these two are correct. These two are correct classifications. These two are wrongly classified cases. Now on that basis, all our statistics will be generated. 2894 are true positive cases. 11750 are true negative cases. All green are success. So what is the classification accuracy? 2894. Summation of all these four quadrants is the total, and the classification accuracy is 2894 plus 11750 divided by the summation of all this is the classification accuracy. And that comes to be 0.899. Is it clear? Okay, now see. That true positive. This is true positive.
true negative. Correctly classified cases, green one, green one, right? Green one. They are correctly classified cases. And pink one, misclassified cases. So the summation of 1, 2, 3, and 4, 2894 plus 11750 divided by the total is the classification accuracy. Now, can you see the Excel sheet? Is Excel sheet visible where classification accuracy is 0.899? Right? Okay, let's proceed further. Now I am giving you one table. Can you see this table, all of you? So what is a precision? The precision is true positive divided by true positive plus false positive. This plus this is a precision. What is the sensitivity? True positive divided by true positive plus false negative. This too is a sensitivity. What is recall? True positivity divided by true positivity plus false negative. Right? What is specificity? True negative divided by false positive plus true negative. Most of the time, we will go for classification accuracy only, which is just simply the diagonals. True positive plus true negative divided by the total number of observations. Is it clear? Is it clear? Say yes or no. Okay. Now, which parameter to rely on? It highly depends on what is more dangerous. Okay. It highly depends on what is more dangerous. Now, what do I mean by what is more dangerous? See, can I consider, friends, can I consider that a person was having a COVID and the kit detected normal, this incident equal to the person normal and the kit detected it as COVID? Can I say that both these events are having equal weightage? Can I say yes or no? Or I can say this part is more dangerous than this part. I am letting go a COVID patient as normal. Is it more dangerous than a person who is normal getting, I am detecting it with COVID? Which is more dangerous? Which is more dangerous? So when that is a scenario, when the classes are not equal, right? So in that scenario, you have to choose the statistics depending on it. So if your false negative cost is more, this one, false negative cost is more, use recall as your measure. If false negative and false positive, they are same, you can go for accuracy or F1 score. And if your FP cost is more, then you go for precision. Is it clear? Now comes the lift chart. Lift chart is also known as a gain chart. Okay, it's a visualization tool to evaluate the performance, that how our model is performing better than the random prediction. Very simple. Just see, can you see this table, all of you? Can you see this table on table? Number of cases, number of responses. Can you see it? Okay, I'll make the things very simple. If I say that there is a 100% probability of any event to occur, and if I divide the entire 100% probability into 10 parts, so each part will have 10%, 10%, 10%, 10%. Now I will arrange the data in the chronology of the number of events occurred. So in the first part, out of 1000 events, 876 events occurred. It means that the total events were 3859. So 876 divided by 3859, 22.70% event occurred in first part, right? What was the normal probability for the first part? 10%. 22.7% divided by 10. So the lift is 2.27. It means that our model is having 2.27 extra power than just the guesswork. Now, if I talk about the second part, 876 plus 743. Yeah, I am repeating. See, if I don't give any model, if I don't make any model, what is the probability that in this particular part the event will occur? 10%. In second part, 10%. In third part, 10%. In fourth part, 10%. But when I have run the algorithm and I have found that number of responses which are predicted. So 876 divided by 3859, 22.70% event has occurred, divided by 10%. So if I don't give any model, it is just 10%. But our model is able to predict 22.70%. So the gain is 2.27. The lift is more than 1, which is quite good. Our model is working successfully. If I talk about the second part, the total number of events which have happened are 876 plus 743, 1619 divided by 3859, right? So it is 41.9%. So the summation of these two, 41.95% divided by 20%, it gives me 2%. So here also the lift is high, model is working perfectly. So whenever my lift is more than 1, the model is working perfectly, right? So with this understanding, right, let's try to run decision tree in STATCRAFT. So in STATCRAFT, I'll go here, import the data, right? And I'll write down the name. You can write down a unique name, Dhaval line. Upload the table, right? I'm using the data set, which is HART1. HART1, open, right? Click OK. Let me explain this now. See, yes, I am having many data because I give training on many softwares. So I have to keep the data set. I will be giving you the brief about myself, that what I am, right? So this is a heart disease, right? And I want to classify that what are the factors on which the heart disease depends. So let's say I will consider only the numeric variable as age, resting blood pressure, cholesterol, and maximum hours of exercise, right? I'll go here and I'll run the machine learning. So it gives me two algorithm, RPART and C5. I'll activate C5 from here. My dependent variable is heart disease. And I want to do the classification on the basis of age, resting blood pressure, cholesterol, maximum hours of exercise. Options. Now there is a concept of seed. Seed means that if I specify a particular seed, a particular number, so it will give me the same result every time, right? So if I'm running the seed as 39, it will freeze it. It will freeze it means it's a random state. Yeah, you got a random state. So if you will run the algorithm at your end and you also specify the same number, 39, it will give you the same result. That's a concept of seed. The parameters which I can change, needless to say, am I giving the equal probabilities or custom probabilities, right? Equal or custom, right? So I can choose the equal or custom probabilities, whatever I want from here. But I'll keep the things equal. Splitting. How do I want to split? Do I want to go for information gain or Gini or information. Let's keep the information gain ratio. Let's talk about the control. I think that all of you know this. Sir, can we give any number to seed? Yeah, you can give any number to seed, any number. But remember, whenever you will repeat that number, the output will remain same. Okay, can anybody tell me what these numbers are? Minimum split, 20. Minimum bucket size, 7. Complexity parameter. More complex you make, more lengthy the decision tree will become. Maximum depth, 13. Cross validation, 10. Plot. Save. You can save the predicted values and the probabilities, and you can click OK. Once this is done, you will get the output here. Now see the intelligence of this software. It's amazing software. It will give you the output also, but at the same time, it generates the code in R. It has generated the code in R. See this? You can say it's automatic intelligence. It's ChatGPT has generated the code automatically. Fine. RPART, what is the equation which we are going to run? That is also given. Now comes the confusion matrix. Okay. We will interpret this thing later on. First, we will see this part. Can you see the decision tree, all of you? Can you see the decision tree? So beautiful decision tree it has given. Now, how it is working, let's try to understand. Your green color represents yes. The blue color represents no. Very dark green color represents more probability. Very dark blue color represents no. So if it is yes, it means that the heart disease is there. And if it is no, the heart disease is not there. Clear? Shall I proceed further? Is it clear? Is it clear? Fine. So we start with the node yes. So 45% are not having the heart disease, 55% are having the heart disease. Now, what is the basic factor on which it will be decided that the person will be having a heart disease or not? So maximum hours of exercise, is it greater than or equal to 133? If it is greater than or equal to 133, yes, go this side. So you will not have a heart disease. Maximum hours of exercise less than 133, no, you don't exercise too much, go this side. Yes, the probability of having a heart disease is 76%. Clear? Is it clear, friends? Is it clear? So interesting, so nicely they have represented it. Fine. Let's proceed further. Let's proceed further. If your maximum hours of exercise are more than 133, let's talk about your cholesterol levels. Is your cholesterol level greater than 43 or less than 43? If it is less than 43, 84% chances are there that you will be having a heart disease. Clear? Is it clear? Is it clear? Fine. Now, again, we will say that my cholesterol level is more than 43. Again, your maximum hours of exercise is more than 160. Yes, it means that you don't have a heart disease. But if it is less than 160, is your resting blood pressure less than 141? No. Then there are 63% chances that you are having a heart disease. Is it clear? Is it clear? Shall I proceed further? Shall I proceed further? Say yes or no. Okay. Now let's see some parameters. It will give you some rules, right? Yeah, you will have to see this complexity parameter, right? What it will do, it will plot a graph. First, it will go on decreasing and then it will again increase. So this is a point where your relative error is very less. So possibly 0.036 is a point where your relative error is completely less. And wherever that point is there, you will decide that the number of splits should be 2. It will give you the answer that this is the optimum splits which you will do. So the number of splits is 2. It means that number of splits is 2 is 1 and 2. You should not go beyond this, otherwise your accuracy will decrease. Okay, number of splits should be 2. Let's proceed further. Let's see the sensitivity, specificity, positive predicted value, negative predicted value, precision, recall, F1, prevalence. The model has a sensitivity of 0.69, meaning that it correctly identifies about 69% of actual positive cases. It also has a specificity of 0.84, 0.76, indicating that it correctly identifies about 76% of actual negative cases, right? The positive predicted value is 0.70, meaning that when model predicts a positive case, it is correct 77% of time, right? Which variable is more important? In drawing the decision tree, maximum hours of exercise is the biggest thing which decides your heart disease. How much exercise you are doing. That is the most important variable. Next comes the cholesterol. And then comes the resting blood pressure. So the decision tree will be divided on the basis of maximum hours of exercise. Is it clear? Shall I proceed further? Is it clear? Shall I proceed further? Say yes or no. Right. Now one more level. Again, I will go here. Again, I will activate the machine learning. And this time I will activate C5. Right? Independent variable, again the same thing. Heart disease. Sorry, not the heart disease. Please, not the heart disease. Heart disease. Then I'll consider age, resting blood pressure, cholesterol, and maximum hours of exercise. Rules, you can say true. Rules we want. Cost. See, I'm having an option. I can change the cost from here. I can give the different cost here. Say, I'll say that here my cost is 0.7 and here my cost is 0.3. I can do this, right? I can do this. I can change the cost here, right? Control, needless to say, what is pruning, what is minimum cases, right? Options, yes, I want the confusion matrix. I want the variable importance, right? Click OK. Now, it will give me the rules. This is the most, this is a very, you can say very clear cut case. Possibly in decision tree, you may have the problem of interpretation, but here it is very clear. No need to worry. It gives the interpretation quite clearly. But let us see the classification accuracy of this algorithm. Is it more than the previous algorithm? 281 plus 426. Is it more than the previous algorithm? So it means that this algorithm is having a better prediction power than the previous one. Do you agree? Do you agree? Yes, we agree. Similarly, we are having sensitivity, specificity, that everything is there. Now comes the rules. Very simple. I will give you one case study and these rules you will be able to understand. You have to write the rule in if the age of the patient is more than 55. The resting blood pressure is between 130 and 145. Cholesterol is more than 123. Maximum hours of exercise is between 132 to 137. Then the probability that the person will have a heart disease, that is the probability that the person will not have a heart disease, is 88.9 percentage. So simple to interpret. Now see, any patient whose resting blood pressure is less than 127, cholesterol is between 123 to 233, maximum hours of exercise is 137, then the probability that the person is not having the heart disease is 80%. What is a lift? Here the lift is 2, which means that our model is 2 times more successful than the random guess. Quite good. Here our model is 1.8 times more successful than the random guess. Quite good. So how many cases are there? 7 such cases are there which follow this principle. Here, how many cases are there? 84 by 16. Here, 195 such cases are there out of 506. So this gives me the rules that when a person will have a heart disease. Now let's talk about this one. If the resting blood pressure is between 134 and 137 and maximum hours of exercise is less than 159, then there are 79% probability that you will have the heart disease. All of you must be watching the IPL, and in that IPL they are showing some probabilities that if the opposition team loses 5 wickets before this many hours, before this many overs, then there are 30% probability that the game will win. Have you seen these statistics? Have you seen these statistics? Yeah. Now the question arises, how many rules we can follow, right? We cannot have many rules and we cannot have 2 less rules because we will have to stop somewhere. So make only 10 rules of the game, not more than that, right? Make only 10 rules of the game. Now, side by side, when I'll click on, it will also generate the probabilities. See, friends, it is also generating the probabilities, the probability and the predicted value. Can you see? This was not there originally, but the software predicted it. So this is all about the decision tree. I hope you enjoyed the lecture.